Hello, welcome back. This is part 3, and this is going to be the last section that I give you guys for today. We're going to have another part of 2.8 that you have video notes on tomorrow, so we're not done with the section, but I think this is going to be enough for you to work on for one night. So we are going to do a problem that is giving us the same type of instructions as what we had for example 1, but as you can see, my equation is a bit more complex. So I'm going to rewrite this equation so that I can have it nice and clearly situated for me to start solving it. Okay. So they want me to solve for x. First thing I have to do is find x. Okay, this is my x. Oh, but so is this. Okay, so already things are interesting because I have x in 2 different spots. I need to get x on the same side by itself. So I'm going to need to move some things so that I don't have x's on both sides of my equal sign, okay? You can't have like x equals something x, blah, 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 and say that you solved for x. Okay, so what is the first thing that I'm going to want to do? Well, I decide, and you can take different routes. I decide I'm going to add 2y to both sides. And I put it off to the side to remind myself that it's not going to combine with either of my other terms here. It's not going to be able to combine with those, but it will cancel out there, and I get 3x equals xz plus 5 plus 2y. Okay? So let me draw my line. Might help. All right. Now, I need to get those x's on the same side, and right now they're still on different sides. So my next step is going to be to subtract xz from both sides. Now, I have to move them together. It would be really nice if I could move just one part of this term, but I'm going to move them together because otherwise I'm just going to make myself a mess. It's safer to move them together, okay? Safer to go in groups, okay? You could think about it like that. That term is like we stick together until we don't. Anyway, so what I get on that side then will be 3x minus x times z equals 5 plus 2y. Okay, we're off to a good start. This is the equal sign, and then I have x and x. So they're on the same side. Now I need to work on the by itself portion. So this is where things get kind of crazy. We have the distributive property, which says like, okay, well, if I have a times b plus c, I'm going to say, okay, well, that's equal to a times b plus a times c, right? So what we have when we do the distributive property is we have that a, we have that piece that we multiplied both of our terms inside the parentheses as like something in there. So basically we can do the reverse of the distributive property. So look at what I'm doing. I'm going to say I'm going to pull x out of these. This is like factoring. I think you guys have done a little bit of that at least. I'm going to say, you know, this 3x minus xz, it's the same thing really as x times 3 minus z. So let me prove that to you over in this corner. That's x times 3, and then minus x times z, 3x minus xz. Okay, same thing. So I can rewrite it like that, and what that does is it makes me only have one x. So that's pretty nice. Now I don't have two of them. The only thing that I have to do, aside from rewrite the rest of my equation, is remove all of the other stuff that's on the same side as that x. 3 minus z is what I will divide by on both sides. X equals 5 plus 2y, over 3 minus z. Okay, that's pretty crazy. I'm going to do another one. For this one, I'm going to do d plus 5c equals 3d minus 1. And I need to solve for d. All right, so if I'm solving for d, I need to first figure out where the d's are. I'm going to look at where the equal sign is so that I can have that perspective. There's a d right here and a d right here, so they're not on the same side. I've got to get them on the same side as one of my first steps, okay? So remember up here when I said that I was going to add 2y to both sides first, but there were different routes that you could really take? So you could have added 2y to both sides as your first step, but you also could have done the subtracting of x and z, and it would have been the same amount of work, basically. So you end up having a little bit of some options on what steps you do in what order. Not a ton of options, because it's still either addition or subtraction, but you can choose. You can choose what you do first. So I'm going to actually say, all right, draw my little dashed line. I'm going to subtract 3d from both sides so that my d's are on the same side. So that cancels out there, and I get d minus 3d plus 5c equals negative 1. Okay, remember that this d that was by itself, that's like a 1d. It's invisible. So 1d minus 3d, what we're really saying is minus 2d plus 5c equals negative 1. Okay. I only have 1d now. That's awesome. The rest of my time is going to be used getting that completely by itself now that it's all in one place. So if you look at this, I still actually have addition and subtraction that I need to do. So I'm going to subtract 5c from both sides. I get minus 2d equals negative 1 minus 5c. Okay, Now, last piece is the multiplication and division, because I have a -2 that is attached with multiplication to my d. So divide by -2, divide by -2, cancels out there. I get d equals -1 minus 5c over -2. Okay, that is not quite going to be our answer, because I said you could leave it like this, but if you have something that can be canceled out of the top and the bottom, then we want to do this. So you see how every single one of these is negative? This is basically like saying a negative divided by a negative, which is going to turn into a positive. I will do a video on that. If not today, I'll do that tomorrow. So you can understand where I'm coming from with that simplifying, okay? I will post something. So really our final answer that we wanted to give is d equals 1 plus 5c divided by 2. All right. I'm not going to give you a try problem for this one. I would rather work on these in class with you tomorrow. So turn in your notes. Come prepared tomorrow for some solving for a specific variable. Have an open mind. And have a good night too. All right. Bye.